right, we have one more day of working with our basic 8 identities. So again, you may want to get these out. Hopefully by now you're memorizing them. You do need to memorize them because we're going to need to know them in order to use them. So hopefully the more you use them, the more you recognize them. So today, they're giving us a left and a right, but you don't have to, when you're doing a proof, which is what they're called, you don't have to always take the left and make it look like the right. If it looks like the right hand side would be easier to do, you can work with the right and make it look like the left, or you can work with both. So there's no set pattern to this. You don't have to do everything on the left hand side. You can start off that way, and if you need to work some on the right, you can do that until they finally are equal to each other. So same information today. It looks like in order to add these fractions together, though, we need a common denominator, and these are not the same. Even though they look very similar, the binomials are very different. 1 minus secant x is not the same as 1 plus secant x. So we're going to need to multiply this fraction by 1 plus secant x over 1 plus secant x, and this one by 1 minus secant x over 1 minus secant x. Alright, so 1 times 1 plus secant is just 1 plus secant x. On the denominator, I get 1 plus secant times 1 minus secant. Alright, then I have plus, and then 1 times 1 minus secant is just 1 minus secant x. 1 plus secant times 1 minus secant equals the right hand side. Alright, once we have this common denominator, we can add the numerators together. So 1 plus 1 is 2. Secant plus negative secant just goes away. And in the denominator, I'm going to go ahead and multiply these together. So 1 times 1, we get 1. And then plus secant minus secant is 0. And then secant times negative secant would be minus secant squared. So now it's looking a whole lot better. Alright, so this 1 minus secant squared, that looks like it might be a version of this Pythagorean identity. So 1 minus secant squared is going to equal negative tangent squared. 1 minus secant equals negative tangent squared. So I have 2 over negative tangent squared x equals negative 2 cotangent squared x. Alright, so here's an example. You could change either one of these. I know that 1 over tangent is going to be cotangent. I know the cotangent is 1 over tangent. So you could change either side, but I'm just going to change this one. This tangent squared in the bottom is going to be cotangent squared. So negative 2 cotangent squared x. That was using this. 1 over tangent equals cotangent. Alright, a couple more examples here. On this one, it looks like the right-hand side has sines and cosines. The left-hand side, the right-hand side doesn't. So this one might be one, even though this is a fraction, there's not much I can do over here because it's already simplified down. It's already sines and cosines. It might be better to work with the right-hand side this time. So I'm going to leave the left-hand side alone and work on this right-hand side. So cotangent, if I'm trying to make it into sines and cosines, remember cotangent is equal to cosine over sine. So I'm going to make this cosine over sine. cosecant is 1 over sine. And so now that I have a common denominator here, I can just subtract my numerators, and I have cosine x minus 1 over sine x. So they're already equal. We're finished. All right, we have one last example here, and again, on the left we've got sine, and it's already simplified, looks like as much as we can. So we probably need to work on this right-hand side over here. And so it looks like on the right-hand side, I'm just going to carry this one down until we decide we might need to change it. So on the right-hand side, remember that this squared means secant x plus tangent x times secant x plus tangent x. So we need to distribute here. So secant times secant would be secant squared x. Then we have a secant tangent on the inside and the outside, so we have 2 secant x tangent x. And then tangent times tangent is going to be plus tangent squared x. All right, so let's see what we can do with that. I think, although we could probably work with this right-hand side a lot of different ways, I think because this left side, it has sines, that I'm going to go ahead and change all this to sines and cosines, like we've been doing. So secant squared is going to be 1 over cosine squared. And then this secant is 1 over cosine. The tangent is equal to sine over cosine. And so this is going to be sine squared over cosine squared. Okay, so let's see what we get there. We have 1 over cosine squared plus 2 sine x over cosine squared plus sine squared over they're all over cosine squared. So they all have a common denominator, so I could add all those numerators. 1 plus 2 sine x plus sine squared x over cosine squared x. Okay, so we still need to get everything in terms of sine. Now, so the top part, it's looking better, but if you look over here, this is not squared. So we need to figure out what we could do to make this not squared as well. So I think I'm going to try factoring that out. 1 times 1, this would be sine times sine is sine squared. And then a plus 1 sine plus 1 sine would give me the plus 2 sine in the middle. Oh, that's looking good, look. All right, and then on the bottom, I also need sine. So cosine squared is equal to 1 minus sine squared. Now we're getting almost to the end because we can see this is looking very similar. So in the denominator here, I can factor that as a difference of squares. 1 times 1, sine x times sine x, 1 positive, 1 negative. And then these just reduce, and there's my answer. Alright, so I didn't ever work with the left, I just worked with the right until it equaled the left. Alright, so again, same tactics. If you can use some, in this case we use some factoring, some algebra factoring. You know, when you add fractions, your common denominator, you can add numerators. along with replacing any equivalencies that we have from our identities. So hopefully we can work with either the left or the right hand side to make them equal.